Hi, everybody. This is Mr. Folly, who's grabbing his pen. And this might be one of the shortest of the short podcasts that we have, because all we have to do is identify what type of reaction we're looking at. So to identify a type of reaction, there's two ways you can look at it. One is to look at the reactants, okay? So for part I, if I have an element plus an element, right? So if I have like N2 plus H2, notice the 2's are there because they're diatomic. That would be synthesis. Synthesis means to make. So we're going to make something bigger, right? For part 2, if I had a compound that decomposes, I might have something like NH3 decomposes. So one compound, notice it's just one thing. Decomposition means falling apart. I like to think of them as zombies. Remember the zombies? And as they chase after you, their arm falls off, right? Still chasing brains. I guess they don't smile, but you get the idea. Okay. And then part 3 is an element plus a compound. And this one's a little trickier because they don't always work, but I'll pick one that works. Li plus KNO3 would be an element, just one thing, a compound, 2 types of atoms. This one has 3, but you get the idea. Li plus K plus N plus O. So, all right. Then 4, compound plus a compound would be double replacement. So this was a little trickier too. There's some ways where it might not work. I'll give you one that'll work. If I have silver nitrate plus sodium chloride. So notice I have a compound, 2 different elements, in this case 3, and 2 different elements. That's how you can tell it's a compound. Okay. And the last one is combustion. And combustion looks a little funny because sometimes it looks like single replacement. O2 plus CH4, for example. So it has to be oxygen. And then it's going to be a carbon and a hydrogen. So see how this is carbon, hydrogen. There might be an oxygen in there, and that's going to be combustion. Okay? So there's some examples for each one. So if I look at this, this is an element plus a compound. And if I'm looking at an element and a compound, I go, oh, that's single replacement. And if I have a compound and a compound, that's double replacement. And then if I have the last one where I have CH and O, notice how the order doesn't matter. I did that on purpose. You get a different one. Now, again, these are the same order. Remember, an element makes one compound. So if I just have a compound, NH3, just one compound. That's synthesis. If I get 2 elements, now I like this because it's N2 and H2, and they're like, are those elements because of the 2's? Yes, they're elements. An element plus an element. This one, number 3, single replacement, I'm going to have them switcheroo. So K and Li are going to change places. I'm going to have K plus LiNO3. And I'm going to get an element, KKK, and a compound, LiNO3. This one's going to give me 2 compounds. I'm going to get AgCl plus NaNO3. Notice how these are both compounds. I am going to emphasize now we need to make a precipitate, which is a solid, which is jumping the gun a little bit, but compound and a compound. And then combustion always makes specifically these exact 2 compounds, CO2 and H2O. So combustion will always have CO2 and H2O. Double replacement, not going to be CO2 and H2O. So if it's specifically CO2 and H2O, that's it. My goodness, we out of here in under 4.5? You better believe it. Toodles.